Hi, I'm Ms. Schomer, and today I'm going to talk to you about pressure conversions. So we can see from this picture, right? Remember that the definition of pressure is how hard and how often these particles hit their container, right? That's what causes that increase in pressure. The problem with pressure is that scientists could not agree on units. So we have multiple different units of pressure. So we've got ATM, atmospheres, we've got kilopascals, we've got millimeters of mercury, and we've got pounds per square inch. So you can see their abbreviation. On the side here, you're looking at just an example of one of them. We've got millimeters of mercury. So this is a barometer. And you can see the air particles, the atmospheric pressure. So there's air particles pushing on this mercury, and that causes this mercury in this tube to go up and down, and you're measuring it in millimeters. So they're measuring how many millimeters of mercury high this glass tube is. So taking a look at this is pushing down, and again, it's pushing this mercury up. So that tells us if there's a higher air pressure, more air particles pushing on here, the higher up the tube it's going to go. If there's less air particles pushing on here, the lower the atmospheric pressure is. So down at sea level, we have a lot more air particles. And then on top of a mountain, you'd have less air particles, so less atmospheric pressure. And again, this one's measured in millimeters of mercury, and that's what it looks like. That's why it's called millimeters of mercury. And Hg is just its symbol on the periodic table. Pressure is measured at sea level. So all of these are measured at sea level, the standard pressures that I'm going to show you. It's also at standard temperature, which we're going to look at and talk about today too. So again, it's at 0 degrees Celsius at sea level. So where the most amount of air particles are is where we took all the measurements for all these different units of pressure. So again, 1 atmosphere, it's all based on pressure. These pressures, here are the actual numbers, right? 1 atmospheric pressure, 101.325 kilopascals, 760 millimeters of mercury, and 14.69 psi, pounds per square inch. All of these were taken at sea level. All were taken at sea level. They're all standard pressures because they were all taken at the same place. Because standard pressure is all related to air pressure at sea level, then all of these are just a different way of saying the same exact thing. So they're all equal to each other. So it's kind of like saying 1 foot equals 12 inches. They mean the same thing. 1 day equals 24 hours. All of these are equal to each other, okay? You may get a problem where it's measured in millimeters of mercury, but the answer wants it in atmospheres. So you'll have to do a conversion. And that's what we're going to look at practicing today. Right? It's important because sometimes we have to convert back and forth from different pressures. So go ahead and take a minute, and I want you to pause this right here and copy this down into your notebook. It's standard temperature and pressure. Sometimes you might get a problem that says, calculate this, and it's at STP. STP means standard temperature and pressure. So all of this means it's taken at sea level. So the temperature is 0 degrees Celsius at sea level, right? Almost where water freezes, and 273 Kelvin, right? Both of those are standard temperatures. And then you have all your standard pressures. You will never have to memorize these for your for like a quiz or test. You'll always be given these, but you have to know how to use them. So let's put it down in your notebook. You'll get used to most of them, but whenever you do a problem, then you can just flip back to this in your notebook, and it's your reference sheet, right? Kind of put a star or put something next to it so that you have it handy when you're practicing problems. Okay, once you're done with that, hit play. All right, so we're going to do a conversion for refresher. I'm going to do the first 2 with you, and then you can do the other 2 on your own. And if your answers are the same, then go on and do the problems in the Go Formative assignment. Otherwise, keep watching the video. So I'm going to flip to my Word document, and let's look at this first one. All right, so we're going to look at 43 pounds per square inch. And I'm going to set these up as like a table. It means the same thing as writing a fraction. So 43 psi. Right, you can set that up and write it as fractions. This table means the same thing. It just allows me to keep going, right? So that's just how I use it. It means the same thing though. Okay, so I always write what I have right here. In this problem, this is what I have. This is what I'm trying to get to. So my millimeters of mercury, I will put my units out here. So I already have it for my problem. Now, I'm going to look at these conversions, right? So I can use these as conversion factors. So these are the last two I'm looking at. So 760 millimeters of mercury also equals 14.69 psi. 14.69 psi equals 760 millimeters of mercury. Okay, so if I take a look at this, in order to do this conversion problem, because we're going to use dimensional analysis, my units have to cancel. So my units in the bottom right here have to be psi. Okay, they have to be psi. And I know I want to get to millimeters of mercury, right? So that has to go on top. When I look at the only conversion that has it that way, it's going to be this conversion. I'm not going to use this conversion, right? They mean the same thing, they're just flipped back and forth. This is the one that I need. So it's going to be 14.69 psi and 760 millimeters of mercury. Now, before we calculate, let's go ahead and take a look at, right, this is 43 psi and this is 14.69. So 14.69 psi equals 760. I have more than 14, right? I have almost about 4 times that. So my number right here should be a lot bigger than 760. Okay, so let's go ahead and calculate it. So starting to think about, does my answer make sense? Should it be bigger or smaller? Take a look at what this says and what this means, right? 14 to 760, those are equal to each other. Well, you have 43. Is your number going to be bigger or smaller? It should be bigger because you don't have 14. So psi cancels. I'm going to cross those out, and I'm left with millimeters of mercury, which is what I want. This is just like fractions. So you take all your top numbers, multiply them, get an answer. Take all your bottom numbers, get an answer, and divide them. So I'm going to take 43 times 760, and you get like 32,680. But I'm going to divide it by 14.69, and I'm going to get 2,224. And I'm going to always go 2 places past the decimal. So I'm going to round. If I need to, I'm always going to go to the hundredths place. So 2 places past the decimal, I can just round that. So should make sense. It's bigger than 760, right? You have 2,224.64 millimeters of mercury. So let's look at the next problem, right? If I have 200 kilopascals, right? That's what I have. And I'm trying to get to atmospheres. So I'm going to put my atmospheres out here because that's what I'm trying to get to. Now, I know that kilopascals have to go in the bottom here because they have to cancel. So even if I get stuck and I don't know anything else, I should be able to figure out, what do I have? What am I trying to get to? So again, like conversion factors, these are equal to each other. So this is equal to 1 atmosphere. This is equal to 101.325 kilopascals. Okay. Well, kilopascals has to be on the bottom, so it's not this conversion factor, it's got to be this guy, right? So 101.325 kilopascals is equal to 1 atmosphere. Now again, before I calculate, I'm going to take a second and I'm going to go, okay, 101.325 kilopascals is equal to 1 atmosphere. I have 200 kilopascals. I have almost double, so this answer should be greater than 1. It should be about 2. So let's calculate. Kilopascals cancels with kilopascals. I'm left with atmospheres. So 200 times 1 is 200, right? Take all your top numbers, multiply them, and then divide them by your bottom numbers multiplied. Okay, so 200 times 1 divided by 101.325 gives me 1.97 atmospheric pressure. It's almost 2, right? It's almost double. So I can tell it's a lot higher. So I should have the correct answer. Now, I'm going to show you the next 2 problems, and you can go ahead and calculate that out. Pause this, calculate that out, and then once you unpause, you can check the answers. If you have them, go ahead and start doing the assignment. If you didn't get them right, then stay with me so that we can continue to practice. Okay, answer to number 3 is 1,535.2. Sorry, that's my 5. That's a bad 5. Rewrite that one. Millimeters of mercury. And then my other answer is 99.73 kilopascals. You got that? Move on and do the practice problems and go form them. You didn't? Let's go through this. All right. 2.02 atmospheres. And I'm trying to get to millimeters of mercury. All right, so atmospheres has to go down here, right? We know that standard pressure is 1 atmosphere, and I'm trying to get to millimeters of mercury, so 760 millimeters of mercury goes on top, right? These things are all equal to each other, so I can set them up as equal to each other, just like 1 foot equals 12 inches. I could flip them either way if I had to. It means the same thing. 12 inches also equals 1 foot. Atmospheres cancels with atmospheres, right? So let's take a look at this. If I have 1 atmosphere and it equals 760, and I have that standard, right? I have 2.02 atmospheres. So my numbers should be double 760, right? Because this is 1, I have double that. So if we take a look at it, right, your final answer, 2.02 times 760 divided by 1, again, gives you 1,535.2 millimeters of mercury. All right, last one, 748 millimeters of mercury. Right, I'm trying to get to kilopascals. Right, this is what I have, this is what I'm trying to get to. I know in order to cancel for dimensional analysis, millimeters of mercury has to go here. Standard pressure at millimeters of mercury, right, because that's what I'm using as my conversion, is 760. And on top, I'm trying to get to kilopascals. So I'm going to put in 101.325, right, because these two things are equal to each other. You can flip them back and forth as conversion factors. Millimeters of mercury cancels, 748 times 101.325, right? And then you're going to divide it by 760, and you should end up with 99.73 kilopascals. If you saw anything wrong, certainly just email your teacher, or if you still need help, attend a WIN session. Otherwise, you should be ready to go ahead and practice the problems on the Go Formative assignment.